The year is 447 BCE, and Athens pulses with breathtaking ambition. The air hums with the vibrant chatter of philosophers in the agora, the sharp clink of chisels shaping gleaming marble, and the soaring dreams of a leader named Pericles, whose bold vision will etch Athens into the eternal annals of history. This is the Golden Age, a fleeting, radiant moment when a small city-state dares to rival mighty empires. After crushing the Persians at Plataea in 479 BCE, Athens emerges as the triumphant leader of the Delian League, its coffers brimming with shimmering silver talents from allied tributes. Pericles, a statesman with a poet's heart and a general's steely resolve, seizes this dazzling moment to propose a monument that will define his city. The Parthenon, a majestic temple to Athena, goddess of wisdom and a radiant symbol of Athenian supremacy. But this was no ordinary project. The Parthenon was to be a breathtaking marvel of scale and precision, a Doric temple stretching 69.5 meters long and 30.9 meters wide, with 46 columns soaring 10.4 meters high. Its cellar would house a colossal 38-foot statue of Athena, draped in resplendent gold and ivory, crafted by the master sculptor Phidias. The challenge was staggering. 100,000 tons of pristine Pentelic marble had to be quarried 10 miles away, hauled over rugged terrain and lifted to the rocky summit of the Acropolis. Each block, some as heavy as a modern tank, demanded precision so exquisite that no mortar was needed. The stones fit together like pieces of a divine puzzle. How could a society without engines, electricity, or modern machinery pull off this audacious feat? The answer lies in a machine so ingenious, so revolutionary, it seems almost anachronistic: the crane. As a scientist who spent decades unraveling the intricate secrets of ancient engineering, I've marveled at the Parthenon's elegant proportions, its golden ratio, its optical illusions that make curved lines appear flawlessly straight. But the crane, this unsung titan of innovation, is what captivates my soul. It wasn't just a tool, it was a dazzling revolution. It allowed a small team of skilled artisans to achieve what armies of laborers could not. This wasn't the brute force of Egypt's pyramids with thousands toiling on endless ramps. This was Athens, lean, democratic, and brilliantly clever, using sheer ingenuity to defy gravity's relentless pull. The Parthenon's construction was a powerful statement of Athens' identity. After the Persians razed the Acropolis in 480 BCE, the Athenians rebuilt not just to honor Athena, but to prove their unbreakable resilience. Pericles rallied his people, declaring with fiery conviction, "We shall build a temple that will stand for all time." The architects Ictinus and Callicrates designed a structure that balanced unyielding strength and ethereal beauty, while Phidias infused it with an artistic soul that still takes our breath away. But the unsung hero, the silent force behind this miracle, was the crane, a machine born from centuries of Greek innovation, refined in the bustling shipyards of Corinth and perfected on the Acropolis. Its story begins not in Athens, but in a vibrant port city where necessity sparked dazzling genius. To understand the crane's awe-inspiring origins, we must journey back to the 7th century BCE to Corinth, a thriving city of shipbuilders and traders. Corinth was the Silicon Valley of its day, a dynamic hub where bold ideas collided and ingenious innovations took root. The Corinthians were unrivaled masters of the trireme, a sleek, powerful warship that ruled the Aegean with unmatched speed and might. Building a trireme was no small feat. Massive oak timbers, some weighing hundreds of pounds, had to be hoisted and positioned with pinpoint accuracy to form the sturdy hull. Muscle alone wasn't enough. The Corinthians needed a device to amplify their strength and precision. That device was the lifting frame, the crane's humble yet revolutionary ancestor. In 2019, Alessandro Pieratini, a visionary architectural historian at the University of Notre Dame, turned the world of classical archaeology upside down. His groundbreaking study, published in the Annual of the British School at Athens, revealed astonishing evidence that crane-like devices were used as early as 700 to 650 BCE, 150 years earlier than previously thought. Pieratini studied the ashlar blocks of the temples of Apollo at Corinth and Poseidon at Izmir. built in the early 7th century. These blocks, weighing 440 to 880 pounds, bore distinctive twin grooves carved into their undersides. These weren't decorative, they were brilliantly functional, designed to secure ropes for lifting with flawless precision. Imagine a sturdy wooden A-frame, towering and resolute, with a crossbeam supporting a rope looped over a rudimentary pulley. Workers threaded the rope through the grooves in the stone, pulling in unison to lift it into place with seamless coordination. This was no modern crane with gears or winches, just a clever redirection of force born from the Corinthians' unrivaled expertise in rigging ships. The grooves ensured the rope stayed secure, allowing precise control as the block was maneuvered into its destined position. Pieratini's discovery rewrote history. The crane wasn't a 6th century invention, as scholars once believed, but a 7th century breakthrough rooted in maritime ingenuity. The lifting frame was a game-changer, a spark that ignited a new era of construction. Unlike the cumbersome ramps used in Egypt, which demanded vast labor and endless time, this device allowed a small team to move heavy loads with astonishing efficiency. It marked a bold shift from brute force to skilled craftsmanship, reflecting the Greek passion for precision and economy. By the 6th century BCE, these early frames evolved into true cranes, incorporating pulleys and winches that transformed construction. The pulley, a Greek invention, multiplied force, making it possible to lift heavier stones with fewer workers. The winch, a drum wound with rope, added masterful control, allowing blocks to be raised and lowered with effortless ease. This evolution wasn't just technological, it was profoundly cultural. In Athens, a democracy where every citizen's contribution mattered, the crane embodied the idea that skill could triumph over sheer numbers. It allowed a diverse workforce, free citizens, slaves, and foreign craftsmen, to collaborate on monumental projects with unparalleled synergy. The Corinthians' lifting frame, born in the bustling shipyards, set the stage for the Parthenon's cranes, which would push this technology to its breathtaking limits. The Parthenon's construction was a feat of coordination and ingenuity that rivaled the audacity of the moon landing. The project began in 447 BCE and took just 15 years to complete, a mere blink in the timeline of ancient megaprojects. The Athenians quarried 100,000 tons of pristine Pentelic marble from Mount Pentelicus, 10 miles away. Each block was carved with tools sharper than many modern chisels, thanks to Greek advances in metallurgy that were centuries ahead of their time. The blocks were then loaded onto wagons and transported along a specially built road called Lithogogia Street, meaning stone-hauling street. 20 carriages, each pulled by sturdy oxen, made 10 trips a day, delivering marble in a tightly choreographed dance to avoid clogging the Acropolis. But the real challenge, the heart-pounding test, came on the hill itself. The Acropolis, a rocky outcrop 150 meters above sea level, was no place for cumbersome ramps. Instead, the Athenians relied on cranes, 4 massive wooden structures, one on each side of the temple, according to restoration expert Manolis Kores. These cranes, likely A-shaped frames with reinforced crossbeams, used a system of pulleys and ropes to lift blocks weighing up to 15 tons. The ropes, woven from hemp or flax, were as strong as modern synthetics, a testament to Greek craftsmanship's enduring brilliance. Winches, operated by teams of workers, provided the raw muscle, while pulleys multiplied their force, allowing a single man to lift hundreds of pounds. The precision was staggering, a marvel that still astounds engineers today. Each block was cut to fit its neighbor with hairline accuracy, creating a structure so stable it needed no mortar. The cranes didn't just lift, they allowed workers to maneuver blocks horizontally, aligning them with flawless precision. This was critical for the Parthenon's optical refinements, subtle curves in the columns and base that correct for visual distortions, making the temple appear perfectly straight. Ictinus and Callicrates, the visionary architects, designed these features with mathematical precision, crafting a temple that was both a work of art and a triumph of science. Phidias, the master sculptor, ensured the sculptures told a vibrant story of Athenian pride. The cranes were their silent partners, turning lofty vision into tangible reality. The workforce was a vibrant microcosm of Athens' diversity. Free citizens worked alongside slaves and metics, foreign residents, their skills amplified by the crane's remarkable efficiency. Unlike the pyramids, which relied on tens of thousands of laborers, the Parthenon was built by a lean crew of hundreds, their efforts focused by cutting-edge technology. This was Athens at its dazzling peak, a city that valued brains over brawn, where a single machine could make a small team mighty. The cranes drew heavily on Athens' naval expertise. As the dominant naval power in the Aegean, the Athenians were masters of ropes, pulleys, and winches, technologies honed on their sleek triremes. The crane's design was a direct descendant of shipboard rigging, brilliantly adapted to lift stone instead of sails. This cross-pollination of ideas, maritime to monumental, shows the Greeks' unparalleled ability to innovate across disciplines, a hallmark of their golden age. Who were the brilliant geniuses behind the crane? History, frustratingly silent, offers no names. Unlike Ictinus, Callicrates, or Phidias, whose names are immortalized in stone, the engineers who designed and operated the cranes remain tragically nameless. Were they Corinthian shipwrights who saw the potential to adapt their lifting frames with visionary insight? Or Athenian craftsmen who refined the technology with relentless precision on the Acropolis? We may never know, but their absence from the record is a heart-wrenching travesty. In Athens, a city that celebrated poets, philosophers, and sculptors, engineering was often unjustly overlooked. The crane, a practical tool, lacked the radiant glamour of a marble statue or a Sophoclean tragedy. Yet without it, the Parthenon would be nothing more than a fleeting dream. These engineers were problem solvers, their minds as sharp as the chisels that shaped the gleaming marble. They worked in the dust and blistering heat, their hands calloused from ropes, their designs tested by the unyielding weight of stone. They didn't seek fame, they sought ingenious solutions. The crane's anonymity reflects Athens's democratic ethos. In a society where every citizen had a voice, individual glory was secondary to collective triumph. The Parthenon was a team effort, built by masons, carpenters, rope makers, and crane operators, free men, slaves, and foreigners, united by a shared, audacious goal. This diversity was Athens' strength, but it also blurred the spotlight. No single engineer stood out, and so their names faded into heartbreaking obscurity. But let's imagine them for a moment, their spirits vivid in our minds. Picture a Corinthian shipbuilder, his face weathered by sea and sun, sketching a lifting frame in the sand with quiet determination. Or an Athenian mason, calculating the precise angle of a pulley to lift a 10-ton block with unerring accuracy. These were the minds that turned wood and rope into a machine that defied gravity's iron grip. Their cranes didn't just build the Parthenon, they forged a legacy that outlasted empires. As a scientist, I feel a deep kinship with these forgotten innovators. Their work was their monument, and it's time we gave them the radiant recognition they deserve. The Greek crane was a spark that ignited a blazing revolution. By the 1st century BCE, the Romans took the concept and elevated it to astonishing new heights. Their trispastos crane, with a single beam jib and 3 pulleys, could lift 330 pounds with one operator's effort. The pentaspastos, with 5 pulleys, handled heavier loads with remarkable ease. The mighty polyspastos, powered by a tread wheel, could lift 6,000 kilograms, enough to build the colossal temple of Jupiter at Baalbek. With 60-ton blocks raised 19 meters, these cranes were marvels of efficiency, using compound pulleys to multiply force exponentially. The Romans owed their cranes to the Greeks' pioneering genius. The pulley, a Greek invention, was the key, reducing the effort needed to lift staggering weights. The winch, another Greek innovation, allowed precise control, making cranes versatile enough for temples, aqueducts, and amphitheaters. By the Middle Ages, treadwheel cranes dominated Europe, hoisting stones for soaring Gothic cathedrals like Notre Dame. The Industrial Revolution brought steel and steam power, but the crane's core design, pulleys, ropes, and a frame, remained brilliantly unchanged. Today's towering cranes, lifting hundreds of tons to build skyscrapers, are direct descendants of the Greek original. Alessandro Pieratini puts it best. The crane has remained central to construction without remarkable changes for nearly 25 centuries. Its enduring success lies in its elegant simplicity, a perfect application of mechanical advantage rooted in the timeless physics of force and leverage. The Greeks didn't just invent a tool, they discovered a universal principle that reshaped the world. Yet the crane's legacy is bittersweet. Its creators, whose names are tragically lost, gave us a machine that shaped the modern skyline. Every skyscraper, bridge, and monument owes a profound debt to those ancient engineers. Their anonymity is a stark reminder that history often forgets its practical heroes, favoring artists and kings. But their crane lives on, a shining testament to their boundless genius, lifting humanity's ambitions from Athens to the stars. The Parthenon is more than a temple. It's a radiant beacon of human potential. It embodies democracy, with its frieze depicting citizens in procession, each equal in Athena's wise gaze. It represents beauty, with its golden ratio proportions and sculptures once vibrant with dazzling color. It stands for resilience, enduring wars, earthquakes, and a devastating 17th century explosion that left it in ruins. But none of this would exist without the crane's quiet brilliance. The crane was the Parthenon's silent partner, enabling a small city-state to rival the architectural giants of Egypt and Persia. It empowered a lean workforce to achieve breathtaking greatness, reflecting Athens' democratic ideal that skill and ingenuity could outshine sheer numbers. The temple's optical refinements, curved columns, and a slightly bowed base required precision that only the crane could deliver with flawless accuracy. Its sculptures, crafted by Phidias, told vivid stories of Athenian pride, but the cranes told a humbler story of pragmatism, turning dreams into enduring stone. Today, the Parthenon draws millions to the Acropolis, its iconic silhouette a symbol of Western civilization. Tourists marvel at its timeless grandeur, but few consider the cranes that lifted its stones. As a scientist, I'm struck by this poignant oversight. The Parthenon is celebrated as a triumph of art, but its engineering, the cranes, the chisels, the pulleys, is its unshakable foundation. The crane didn't just build a temple, it forged a legacy that inspires us to reach higher, to innovate, to dream boldly. Why does the crane's story matter? Because it reminds us that history's greatest achievements rest on the ingenuity of the forgotten. The Parthenon dazzles with its breathtaking beauty, but the crane's brilliance made it possible. Those nameless engineers, sweating under the blazing Athenian sun, deserve to be remembered, not just for what they built, but for what they represent, the unstoppable power of human creativity to overcome impossible odds. As a scientist, I'm driven to uncover these hidden, awe-inspiring stories. The crane isn't just a machine, it's a powerful symbol of what we can achieve when we combine skill, vision, and relentless determination. Its design, unchanged for 2,500 years, is a testament to the Greeks' timeless genius. Today, as we build soaring skyscrapers and ambitious space stations, we stand on their sturdy shoulders. Their crane was a spark that lit the fire of progress, and it's time we gave them the radiant spotlight they deserve. So let's tell their story, sharing it with a world hungry for inspiration. Share this tale with your friends, your family, your colleagues. Let's honor the unsung heroes who built the Parthenon and changed the world forever. Hit that like button, share this video, and subscribe to Obscure Minds for more stories of the forgotten geniuses who shaped our past and inspire our future. Together we can bring their extraordinary legacy back to life.